So now in this unit, we will be approximating the area under the curve using in rectangles, and these rectangles are called Riemann sums. So we have to start with a given interval, a to b. And if we're breaking it into in intervals, we think about the base of each rectangle is going to be the endpoints or the difference of the interval divided by the number of rectangles that you want. So this is the base of each rectangle. So the base of each rectangle is delta x. Now the height of our rectangle is our function evaluated at a given x value. Now where that x value comes from depends on whether you're using left, right, or midpoints. So if you're using left endpoints, that means you'll start on the left from each of those delta x intervals to get the height of each rectangle. You can also instead use the right side of each interval. So each delta x interval, you could only use the right side to find each height. Or the third way to use a rectangle is to find the middle of each delta x base and use that to find the height of each rectangle. As you can see, whether you use the left, the right, or the midpoint, there's always a little extra area that is not accounted for or that you go over. So you can see that using Riemann sums is always going to be an estimate of that area under the curve. So it's important to determine whether your estimate is an overestimate or an underestimate. And honestly, we focus on this most on the AP exam with left Riemann sum versus right Riemann sums. So if it's increasing function, increasing positive slope, left is an underestimate, right is an overestimate. And if it's a decreasing function, a left Riemann sum is overestimate and a right Riemann sum is an underestimate. So we'll use these ideas in the next examples.